Now I'm going to discuss with you the logic of reversal designs, which is really grounded in what's called baseline logic. Baseline logic was first described by Sidman in 1960, and it involves a steady state. And by steady state, I mean consistent responding with little variation over a period of time. Now let's talk a little further about baseline logic. Baseline logic entails three elements: prediction, verification, and replication, each of which depend on an overall experimental approach called a steady state strategy. Okay, so we know what steady state is. I'm going to move that definition down here for you. And now let's talk about steady state strategy. Steady state strategy entails repeatedly exposing a subject to a given condition while trying to eliminate or control any extraneous influences on the behavior and obtaining a stable pattern of responding before introducing the next condition. So we want to use steady state strategy as we consider our implementation of our interventions, and you'll need to apply this to your thinking to help inform you when you should move into the next phase of your study with the project that you're implementing this semester. So let's talk about this in terms of the withdrawal design shown here. First, we have baseline, and one of the purposes of the baseline is descriptive. This initial baseline shows us how the behavior is performed at present without the intervention having been introduced. And we want to get a steady state of that behavior initially. And so I'm going to delete these now, and we're going to talk about the three components of baseline logic, which are prediction, verification, and replication. So the first thing that we have here is prediction, and I'll talk about that one first. I'm just going to highlight these in different colors to help us as we look at some things here. So again, this initial baseline here is prediction, and what it's doing is telling us how the behavior would likely continue if we did not intervene. Okay, so if we didn't intervene, this behavior has a pretty flat trend, okay, and we presume that it would just continue in this way or potentially reduce over time, okay, without any type of intervention. But then we introduce the intervention, and we see an effect. We see a change in the behavior, an increase in the behavior in this case, following baseline. So the behavior did not continue as predicted, which means that the intervention probably is what caused the change in the behavior. But we don't know that for sure. So we reverse back to baseline, or we withdraw the intervention, and that's where you get the term withdrawal. Withdraw the intervention, and we see that the baseline is beginning again to show this decreasing trend, this decreasing slope, similar to prediction. It's a little bit higher, but what this does is this second return to baseline is a verification. Okay, it verifies that if we hadn't conducted the intervention, the behavior would likely have stayed as we predicted. It verifies that. And with this, we have a causal example. Okay, it doesn't meet standards as far as how we would write a study and have it published in a peer-reviewed journal, but it does demonstrate that there is an experimental control, that when we as the experimenter introduce the intervention, the behavior changes, and when we withdraw the intervention, the behavior returns back to baseline. So we've demonstrated prediction and verification. But then we also want to predict replication, a replication of effect. And so that is done by returning the back to the intervention. So this replication has been demonstrated twice over. We first had the baseline introduce the intervention, and then we were able to replicate that again by returning back to baseline and back to intervention. And we have a clear demonstration of experimental control. We are certain that it is the intervention that caused the change in behavior because we were able to replicate it, and we were able to verify that without the presence of the intervention, the behavior would return back to baseline levels. Now let's talk about what happens if we encounter some problems in our data and ways that we would not be demonstrating experimental control or a functional relation. So here's the same study, but in this study we have a prediction here that looks like this. Oops. That looks like this. Right here in baseline, it's predicted that the behavior, if we didn't do anything, would continue in this fashion. And what happens during intervention? The behavior continues in that fashion. So we see here that the behavior was already beginning to increase, and we can't be sure that the intervention had any effect on the behavior because the behavior was already moving in that direction, was already increasing over time. And so what you would want to do if you were the researcher in this case was not to introduce the intervention until we saw the behavior begin to level out. So we wouldn't change phases, we would stay within intervention, and we might have these data points here that show an increasing trend, and then eventually the data stabilize. So remember, when you're conducting a research study, as in the project that you're studying now, you don't enter the intervention after 5 data points because you've met the requirements for a study that meets quality standards. You determine when you enter that intervention based on the data, based on seeing a steady state of behavior. Okay, and so that's what we would do here if we saw this increasing trend and we wanted to increase the behavior. We would want to see, is the student just going to increase independently, in which case that student does not need the intervention, or will the student eventually demonstrate a steady state that indicates the student does need an intervention to increase the behavior. And so if we waited and the data began to look like these data here, not that they're very pretty data, but they do the job, then we would know that now we could introduce that intervention. So you want to be sure that when you're conducting research, you wait until the data demonstrate a consistent trend or a steady state that indicates that the intervention is needed and that you can go ahead and introduce the intervention. And you may be able to do that within 3 data points, but you may not. And so you really want to watch the data to see before you determine when to enter that phase. I'm going to erase these scribbles real quick and take us back to the original graph. In this instance, we should not have entered intervention and should have waited for the data to stabilize or for the student to demonstrate that he or she did not need an intervention in order to achieve appropriate levels of the behavior. We cannot demonstrate a functional relation based on the data that you see here. Here's another potential problem that could occur. We have a steady state in baseline. We see a quite dramatic change in behavior following intervention, and then we return back to baseline and we see that the behavior is beginning to return to initial baseline levels. But then when we reintroduce the intervention, the behaviors continue to decrease to lower levels than, or levels still consistent with the initial baseline. And what that tells us is that this behavior change was likely not due to the intervention. There may have been some other confounding variable or influencing variable that changed the behavior to this rate, but it is not the intervention because we were not able to achieve replication. Remember, a functional relation indicates that in the presence of the intervention, the behavior changes. And here we were not able to replicate that effect, and therefore there isn't a functional relation, and we're not really sure what it was that changed the behavior in this phase. Finally, let's look at a graph from the readings that you had this week. So here is a reversal design. It was in 1964, so they don't really meet the types of standards that we have for drawing single case design. So I'm going to draw some phase change lines here. They do have the phase change lines. They just didn't draw them all the way through. But to make it a little bit clearer, I'm going to do that. Okay, so what we have here is baseline, intervention, return to baseline, intervention, and then we have some maintenance checkups. Okay, so I could have very easily written AB, AB here. The use of AB, AB is to demonstrate a pattern. It's not required that you write AB, AB. And in fact, when you do your research, generally you're explicit about what that intervention is here. You don't write the word intervention. In this case, it's reinforcement to interact with children. So you might write reinforcement because that's what the intervention is. So we see here, it may be a little bit confusing, but what we're looking at is the folks in this study wanted to change the students' behaviors so that they interacted more with children than they did with adults. And so if we look at baseline, initially the percent of interaction that these students initially had was greater with adults than it was with children. And they wanted to increase the amount of time that the students interacted with children and decrease the amount of time that the students interacted with adults to make them have more socially appropriate interactions during their time at school. So they introduced an intervention that would reinforce behaviors for the students any time that they interacted with children. Now, if we think about prediction, we would predict that without the intervention, the behavior would be consistent and would continue in this fashion. Okay? That's what we would predict. And then here we have verification that when we reversed, the student went back to baseline levels regarding the amount of time spent with adults. And let's see if that happened with students. And we see yes, we have a verification here. This prediction is that the behavior would continue at this low level, and it's verified when we return back to baseline. Okay, and then we see that we have a replication both in reducing the rate of behaviors of interacting with adults and increasing the rate of interacting with students. And we can say that there is a functional relation between reinforcement for interacting with children and the percent of interaction with adults and children. The students consistently reduce their interaction with adults and consistently increase their interaction with children in the presence of reinforcement. And that is a discussion of prediction, verification, and replication, which forms the basis of baseline logic. In the next video, I will briefly discuss with you the limitations regarding reversal designs.